Alright, here's our worksheet on graphing velocity practice. Okay, this worksheet has a variety of different sections. You are welcome, of course, to jump around as you please. I recommend you start from the beginning. So, here we go. Draw a distance versus time graph for the data table below. So here's our data table. And choose the correct description of the motion of the object. So here's our descriptions. You're going to pick A, B, C, or D to describe the motion of the object. Here's the data, and we are going to graph it. It's a little graphing practice. Alright, so time 0, 1, 2, 3, 4, 5, 6. We have a total of 6 seconds, so time going across horizontally. Alright, now if you pay close attention, this is actually the reference point. So you might want to emphasize that so that you don't get confused. Okay, so that's your reference point right there. Alright, or your x-axis. And of course, here we have our y-axis. Alright, so first plot the points, then connect the dots. So at a time of 0 seconds, so 5, 4, 3, 2, 1, 0 seconds, we have a distance of 8 meters. So plus 8 meters at a time of 0, get a dot right there. At 1 second, we have 6 meters. There we go. At 2 seconds, we have 4 meters. So at 3 seconds, distance of 2. At 4 seconds, distance of 0. So at 4 seconds, this object, whatever's moving here, is at the reference point. At 5 seconds, 2 meters past the reference point in the negative direction. At 6 seconds, 4 meters past the reference point, from the reference point in the negative direction. Okay, so a bunch of dots right there. If you got a ruler, any straight edge, doesn't have to be a ruler, but a little bit easier that way. Connect the dots. Alright, so which of these, A, B, C, or D, describes the movement of this object? Well, at 0 seconds to 1 second, the object goes from 8 meters away from the displacement to 6 meters away. And then it's only 4 meters away, and then it's only 2 meters away, and then it's at the reference point. Okay? So, is it moving at a constant speed away from the reference point? Well, it's not moving away from the reference point, so it can't be A. Okay? Is it moving at a constant acceleration away constant acceleration? So this one said constant speed. This one says a constant acceleration away from the reference point. Well, again, it's not moving away, so it can't be B. Moving at a constant speed toward the reference point, okay? Toward the reference point. Now that whole, remember, linear means we've got a constant speed because of a distance versus time graph. Linear means constant speed. Toward the reference point, past the reference point, and keep going. That sounds like a very good possibility. D, moving at a constant speed towards the reference point. Well, that's true until we get to 4 seconds. But after 4 seconds, he's no longer moving towards the reference point. He's moving away from the reference point. So C is the correct answer. D is just incomplete. Okay. So that's the first section. Second section, match each graph with its description of its motion below. So we have a graph. This one actually looks very similar to this one. Starts off very similar. Then it stays at the 0 displacement and then continues downward. Okay? This one starts down here, really steep line, and then a less steep line, and ends at the reference point. This one's starting at the reference point. Remember, horizontal means a constant position, or not changing position, which means at rest. And then it's very slow speed, and then we got a slightly faster speed. So match them. We have 3 graphs, and we've got 4 descriptions, so you need to match and figure out which ones are which. Okay. So let's just start with A. Start in a negative position. Well, this one is starting in a positive position, because remember, that's 0, these are positive, these are negative. Okay, so it's not that one. This one starts in a negative position, so that's a possibility. Okay. That one starts at the reference point. Okay, so this might be this one. Let's keep reading. Move fast away from the reference point. All right, well, a steep line means moving fast. Okay. Away from the reference point, well, as time passes here, is moving further and further and further and further and further from the reference point for that, so that works. Turn around and move slower back to the reference point. Okay? Moving slowly towards the reference point, and it's slowly because that's not a steep slope. Okay? Or it's slower. Okay, so slower meaning a less steep slope and back to the reference point. So yeah, that one matches. So A. Okay, let's look at C. Start at a positive position. Okay, so that could be this one. This one starts in positive. That one at the reference point. Move at a medium speed toward the reference point. Okay, so medium speed, not super steep, not super shallow. So that's a possibility. Moving towards the reference point. Stop at the reference point for a few moments. Okay, this is stopped and it's at the reference point, so that fits. For a few moments, so it's not just instantaneous, it's for a moment. Then continue in the same direction with the same speed. So the same direction, even though this is moving towards the reference point, remember that negative slope, moving in the negative direction, negative slope, negative direction, those slopes are about the same. So, parallel lines, that matches. There we go. Alright, look at B and D. We've got to find the description for this graph. Start at the reference point at rest. Alright, that's definitely a possibility. Slowly move in the positive direction. Okay, positive direction, positive slope. Going uphill, it's a positive slope. Okay, increase the speed and continue in the same direction. Okay, so it's moving the positive, moving slowly. Okay, notice very small slope. Right there, very small slope, that's moving slowly in the positive direction. Increase the speed and the same direction. So it's still positive slope, but it's just a little bit steeper. So yeah, that description matches. Okay, D, start in a positive position. Alright, this is the only one that started in a positive position. Move away from the reference point. Well, this one's moving towards reference point, so we're definitely not using that one. Okay? For these three graphs here, we're going to describe the motion for each of the three graphs relative to the reference point. So just like these descriptions, we're going to now write the descriptions ourselves rather than just matching. Okay? So here we go, describing motion. Use these kind of as a guide to kind of inspire you. Okay, so each one of these always talked about where it starts. So right here, there's a reference point, that's positive, that's negative. So description for this graph, start negative position. Now, is it moving towards the reference point or away from the reference point? Well, as time passes, it gets closer and closer and closer. So move towards the reference point. And I'm just going to put RP because I'm too lazy to write reference point. Okay, so move towards the reference point. Right here, you pass the reference point. And keep going. Alright, so that constant speed, I should that. At a constant, well, this is a displacement graph, so I'll say velocity. Okay, at a constant velocity. Right here, that horizontal, okay, stop in a positive position. So it's a positive, it's in a positive position. Alright. Stop for a few minutes. Why not? Okay. And then right here, that one, return that movement. Notice it's moving closer and closer and closer back to the reference point. So return to the reference point. And return to the reference point. There you go. Alright, I want you to try to do these two. Okay, emphasize where it's starting. It's relative to the reference point. You can talk about speed. Okay, so notice this one has a very small slope, so that's going to be moving very slow. Here, a super steep slope, so that's moving fast. Horizontal, at rest. Okay, right here, super steep, starting at the reference point. Super steep, super steep, and then not so steep. So remember, if it's positive slope, it's moving in the positive direction, negative slope, negative direction, okay? In this case, this one's moving away from the reference point, moving towards the reference point, and moving away from the reference point again. So moving very fast away from the reference point, moving very fast towards the reference point, and then moving slowly away from the reference point again. Here we're starting a positive position, moving slowly away from the reference point, and then start moving very fast towards the reference point, past the reference point, and then stay at rest. Okay, so you can check your descriptions there. Alright, now for the back side. This time we're now going to match the graphs to data tables. Alright, 4 graphs, 5 possible data tables. See how well you can match them. Okay? So, this graph, sorry, missing its y-axis there. Alright, so here, let's just look at the first graph right here. I need it to start in a positive position. The number is going to get bigger, and then it's going to get smaller. It'll hit 0, and then it'll go into the negative, and then it'll stay at the same number negative. Okay? So start in a positive. Can't be that one. It could be B, C, or E. Okay? B, C, or E. Alright, starting a positive. Moving slowly. Increasing slowly. Alright, so 10 to 5, that's decreasing, so it can't be B. So we're down to C or E. Okay? So increasing slowly, 5 to 10, 5 to 7. 5 to 7 doesn't work, a slow increase. And then suddenly negative 5, where this one was 10, and then 10. That means he's at rest. This isn't at rest up here. So from positive 7 to a negative 5, a sudden change. Alright, and then negative 5, a negative 5, a negative 5. So I would say this one is E. Okay? So we've used that one. Alright, next one, starting at the reference point. Well, at time 0, position 0, there we go. Then suddenly, really big number, and then not so big. So all the way up to 10. So if you think about that, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 10. And then, so that's all the way up to 10 right there. And it goes back down to 5. And then slowly climbs its way back up. So yeah, that one's D. Okay. Negative position. This one starts in the negative. Well, only one of these graphs starts the negative. And then it gets to the positive. And it stays there for a little while, and then it goes back to the reference point. So that one would be A. Alright, and so we've done E, A, and D. So this one's going to be B or C. Starting positive. Okay, they both start positive. They reach the reference point and stay at the reference point. Well, at rest at the reference point, there you go. Position of 0 for a couple seconds, and then goes into the negative. This is B. Alright, now for this. Race results as our title. This is a displacement versus time graph. We have 1, 2, 3, 4 graphs. Alright, the solid line is Daniel. This dotted line over here is Roberto. This one right here to the far right, that's Jose. And this short one right here, that's Pablo. Alright, so use the graph to answer the questions. So who had the fastest average speed? Alright, fastest speed means the steepest slope. Okay, you need to know that. Fastest speed means the steepest slope. Well, which graph has the steepest slope? Alright? You should know that from algebra. There's your steepest slope right there. So, Roberto. Alright, slowest speed would be the least slope. Alright, well if that's the steepest, little less, there's your least. That would be Jose. Alright, who was 40 meters from the starting line at 10 seconds? Well, time's down here. It's 0 seconds, 5, 10, 15, 20, 25. We're paying attention to the 10 seconds. So at time 10 seconds, this graph, where each of these graphs are at 10 seconds. Alright? Who was 40 meters from the starting line? So the starting line is where they all start. So starting line is position 0, time 0. That's where everyone is when the stopwatch starts. They're all at the starting line. So that's starting line. 40 meters from the starting line. So 10, 20, 30, so 10, 20, 40, 60, 80, 100. Right there, 40 meters from the starting line at 10 seconds. That is Jose. Okay. Who never finished the race? Well, you see that Roberto got to 100. Pablo got to 60. Daniel got to 100. And Jose got to 100. So, who never finished? Well, that would be Pablo. He only got to 60. He didn't get all the way to the 100-meter position. How far did he get? He got 60 meters. How long was the race? Well, if you notice, Roberto, Daniel, and Jose, they all went a displacement of 100 meters. That would have been the length of your race. Okay? Alright. Calculate Jose's speed. We want to calculate speed. Well, speed, same thing as velocity, almost the same thing, except it's just distance over time. Alright? But here we're given displacement, pretty much the same thing because we're not talking about direction. We don't know what direction really it's going. Slope is the rise over run. Okay, you can use that if you want to, or you can use this. This is the rise. Displacement rises, time runs. Okay, rise over run. So we want to calculate the slope because the slope equals the speed. Okay? So if we can figure out the slope, we can figure out the speed. So a couple different ways to look at that. So Jose, we need to focus on Jose's graph. So this graph over here. Okay? So you can calculate, if you want to, notice you start at 0, displacement of 0, time of 0, starts at 0. Okay? We're going to rise or have a displacement. Let's just go to the end of the graph, 100. Alright? 100 meters. That's his total displacement. How far does he go? How much time horizontally does that take? 25 seconds. Now notice displacement divided by time. Displacement divided by time. Okay? Or distance divided by time. That gives us our setup. So, calculator, 100 divided by 25. That is 1/4. 0.25. Sorry. Back up. Made that wrong. 100 divided by 25 is 4. Show the calculator here. 100 divided by 25 is 4. So 4 units, meters per second. Remember, meters per second, those are units for speed. There we go. 4 meters per second. Alright. Oh, calculated speed using the velocity displacement. There you go. So the displacement divided by time. Displacement of 100 meters. time of 25 seconds, 4 meters per second. Okay? Rise over run, so you want to do rise. Maybe rise 60, run 15. Rise 60, run 15. You want to do that point right there. 60 divided by 15 gives you 4. Doesn't matter any point you pick along here. 80 divided by 20. You get 4. Any point along there, you're going to get that. That's the slope. 4. That's the speed. Okay, so compare your questions for 6 and 7. What is the relationship between slope and velocity in a displacement versus time graph? The relationship between slope and velocity. The slope equals the velocity, or the slope is the velocity. Okay? That is your worksheet, graphing velocity practice.